purpose of this video is to review the basic operation of the GED stainless steel glass washer. We will discuss the machine layout and options, as well as the function of the switches and controls to operate the machine. Before we get started, let's discuss the appropriate PPE. In the window and door industry, the presence of glass is so commonplace that we sometimes forget the fact that we may be working with or close to it without wearing appropriate PPE. Your company should have its own safety policies and recommendations for PPE, but let's take a minute to discuss some suggestions. Before entering the washer area, make sure you have the appropriate PPE, which should be no less than the GED recommendations in this video, or what's required by your company's safety policy. Use your best judgment to protect yourself from potential injury. As a minimum, you should have safety glasses, cut level 5 gloves, Kevlar sleeves, Kevlar or leather apron, and steel-toed shoes with metatarsals. An anti-cut sweater may be worn instead of sleeves, but may not protect below the waist, so a cut-resistant apron should still be worn. If you are handling glass over shoulder height, then a hard hat, shoulder, and neck protection should also be worn. Ordinary daily clothing is not protection against sharp edges of glass and should never be considered as personal protective equipment. Improper protection can result in serious injury or even death. In addition to having appropriate PPE, also ensure safe glass handling practices are followed. This includes, but is not limited to, the washer operator being the only one in the loading zone between the harp carts and the washer. Always inspect the glass for defects or damage that could cause breakage when glass is handled. Glass should be handled with palms outward, holding the glass away from your body, so if it had to be released in an emergency, it would likely fall away from your body. Never carry glass under your arm or hold it against your body. Carry glass vertically, then support it with the entry rolls when transitioning to the horizontal position for loading the washer. Get help with larger lights. Carry low and on the same side. With both people on the same side, the glass could be released in an emergency and fall away from both, rather than trapping one of them. The illustration here shows a basic layout of the GED glass washer. As viewed by the operator, the left side of the machine is the brush motor side, and the right side is the non-brush motor side. The washer has 4 tanks, which are the pre-wash, wash, first rinse, and final rinse. The pre-wash section removes large particle matter, such as interleaving or lucor, and general dust and dirt. The wash section is the only heated section, which aids in the removal of oils and cutting fluid residue. The first rinse tank removes any soap, chlorine, or other organic molecules that may migrate from the wash tank. And the final rinse tank has the cleanest water to provide the cleanest possible glass for production. There are several configurations for the washer, ranging from no filtration to specialized filters for each tank, excluding the wash tank. These variations are explained in more detail in the video on glass washing techniques. Let's take a look at the switches and controls on the washer. The main power disconnect, which turns on and off the power for the washer, is located on the main electrical cabinet on the brush motor side of the machine. This is also the lockout point for the electrical. Before we power up, let's open the non-brush motor side of the machine to make sure that our tanks are ready to go. Ensure the tanks have been drained, rinsed out, and the risers installed. Be careful not to cross-thread the threads when installing the risers. A standard washer with no filtration has 3 pumps, one each for the wash, first rinse, and final rinse tanks, which should each have a riser in place. Since this 96-inch washer has a GED AquaSave Filtration System, the pre-wash tank will also have a water pump and the riser installed. The tanks will automatically start to fill once the main power disconnect is turned on, provided the water supply is on. Each tank has a float switch on the brush motor end that will call for water when low and shut the water off when the tank is full, similar to a float in a toilet tank. Each tank also has a low-level float switch. If any of these float switches drop too low while the machine is running, the water pumps and conveyors will stop to protect the pumps. If the water level in the wash tank drops too low, it will also turn off the heaters in addition to the pumps and conveyors, protecting both the pumps and the heating element. There are two emergency stop buttons on a standard 60-inch washer, one at the entry end and one at the exit end. Larger washers have a third button on the right or NonBrush Motor side of the washer. An emergency stop button, or E-stop for short, stops all motion on the machine, which includes conveyors, brushes, and blowers. Both side covers of the washer have magnetic sensor switches that will also cause an emergency stop condition if the covers are opened or removed. There are two control boxes, one for the entrance controls and another for the exit controls. On the entry control box, there is a master start button, a heater alarm indicator light, a bypass mode switch, and a washer stop button. The master start button performs three functions, each depending upon the state of the machine and how many times the button has been pressed. The first press of master start after the power is turned on turns on the water heater. The green light will flash fast, indicating CRM, the main control relay, is engaged and the heater is on. If the red light is off, the heater is on and the water is within the operating temperature range. If the red light flashes at a slow rate, the heater is on, but the water is not within the operating temperature range. If the red light flashes fast, the low water level switch will be open, which disables the water heater. The second press of master start starts the water pumps, brush motors, and blower motors. This is referred to as a washer start cycle. The red light must be off before the washer start cycle will initiate, which indicates the wash tank water is up to the set point temperature. The exception to this is if the bypass key switch is on, which is not recommended for production use. All tanks must be filled before the washer start cycle will initiate. The third press of master start starts the conveyors. Additional presses of master start toggles the conveyors on and off. When the conveyor is toggled off, the green light will slowly flash, as will the green light on the exit controls, which always mimics the master start light. When the conveyor is toggled off with the master start button, the machine is idle and the water save function is active. Water save active means the water pumps and the final rinse solenoids switch off, but will periodically turn on to keep the brushes wet. Pressing the washer stop button stops everything except the water heaters. This is typically used when the machine will be idle, such as at break time. The machine reverts back to the state when master start was pressed for the first time. The wash tank heater will be on, but the pumps, brushes, blowers, and conveyors will all switch off. Press master start twice to restart after the washer stop has been pressed. The first press restarts the pumps, brushes, and blowers, and the second press starts the conveyors. It is recommended that the washer is started 15 to 30 minutes before running production in order to hydrate and soften the bristles of the brushes. This helps prevent scratches on low E coatings. The bypass key switch allows you to operate the machine even though a low water temperature alarm condition exists. If the water temperature falls below the set point, the heater alarm light will flash slowly and the conveyors will stop. If you want to run the machine anyway, switch the key switch to the bypass on position. The red heater alarm light will be on steady, indicating the water temperature is low and the machine is in the bypass mode. The heater alarm light will turn off when the water is back up to temperature. Using the bypass mode is not recommended for running production, as the glass may not be properly cleaned. The heater alarm light has 4 states: off, slow flash, on, and fast flash. When the light is off, it means that there is no problem. The water temperature and water level are okay. A slow flash means that the wash tank water temperature has fallen below 120 degrees Fahrenheit. If this condition occurs, the pumps and conveyors turn off, but the heaters stay on. When the light is on, this means the wash tank water is below the set point temperature and the bypass switch is on. A fast flash means the wash tank water level has fallen below the low level float. If this condition occurs, the machine shuts down, the heaters turn off, as well as the pumps and the conveyor. If your machine is equipped with an optional process monitor module, there are additional alarm conditions pertaining to the water temperature in the wash tank. See the process monitoring module option in the user guide for more detail. The exit controls consist of a conveyor slow button, a heater alarm light, an e-stop, and a conveyor speed dial. The conveyor slow button puts the conveyor into a creep mode, where it runs very slowly, allowing the operator to essentially pause the machine without stopping the lights in the brush sections. This prevents brush damage to the low E coatings. When in the creep mode, the conveyor slow and master start lights flash slowly. Additional presses of the button will toggle the conveyors between normal speed and creep mode. There is also a foot switch located at the end of the exit conveyor, which performs the same function as the conveyor slow button. The heater alarm light functions the same as the one at the entry conveyor. The exit control's e-stop button functions the same as the e-stop on the entry conveyor. It will stop all machine motion. The conveyor speed dial allows the worker at the exit end of the washer to control the conveyor speed to keep the washer rate synchronized with the rest of the production line. Ideally, the speed should be set as fast as possible to maintain production while still getting clean, dry glass, and may be used to slow the conveyor if the lights are getting backed up in the washer, or speed it up if there's too much wait time. It is a washer operator's responsibility to pace the line. Feeding the glass too quickly and too close together will result in glass-to-glass contact, damaging the edges of the lights, which will likely cause premature IG failure resulting from stress cracks, which may occur at the weakened area. Feeding glass too far apart will negatively impact production throughput. As you can see, the washer operator plays a key role in pacing the IG production and ensuring proper orientation of components. Down and to the right of the exit controls is an air regulator that blows air into the brush bearings to keep water out. This must be on and set to 25 psi. If the pressure is below 20 psi or above 30 psi, the conveyors will be put into a creep mode. Moving to the other side of the machine, on the NonBrush Motor side, there are 4 flow control meters and regulators. Use the regulators to set the water flow rate to the spray nozzles based upon the size of the washer, as outlined in the user's guide. To the exit of the final rinse tank is the air knife section, which blows filtered air across the glass to dry it. The top and bottom air knives are at an angle to the conveyors, so when the glass is fed in squarely, the air pushes the water off the glass to the trailing corner. An optional air knife kit may be added to the top air knife to accommodate thicker or wavy tempered glass. Before getting started, ensure that the filtration system is properly set up and ready. With the AquaSave system, make sure all the bypass valves are in the service mode and the main disconnect is on for the final rinse pump. The indicator light on the final rinse system for the DI water should be green. If red, then the DI tank needs to be changed by a maintenance technician. For more information on glass washing, see the videos on glass washing techniques and the glass washing demo.